Hello everyone, welcome back to our lecture on desert landscapes for Geography 101, Earth Systems. Today we're going to continue our discussion with talking about coastal dunes. So definitely coastal dunes are a big part of the New Jersey landscape, and they show a lot of resemblances to the dunes that you might see in the Sahara, for example. Dunes, coastal dunes, are ridges of sand above the high tide line formed by both wind and waves. And you can see here that aeolian transport, that wind-caused transport of wind, as well as the movement and accretion of sand onto the landscape by waves are important for building up dune structures. Usually, dunes along the coast require some amount of debris, such as wood and sticks that are deposited, or vegetation that can grow along the shoreline in order to form initially. And so dunes generally form a characteristic successive pattern as you move farther away from the shoreline. And we're going to learn about that now in this video here.
So sand dunes, when you're drawing the diagram, are formed of 6 types of dunes, and normally they start from the small and they get larger as they move further inland. This is with the exception of the last dune, which is slightly smaller because it's basically run out of sediment. Now, the way that dunes are formed is they're formed by the wind picking up little sand particles and bouncing them along the beach, and them getting trapped by some sort of feature that's found on the beach. They typically start from the berm, which is the upper part of the swash, and it forms this kind of like little ridge inside, on the coast, and sediment gathers there. Now, eventually what will happen is that vegetation will accumulate on this berm, and the vegetation will trap additional sediment, and these little embryo dunes will then get bigger and bigger and bigger. They'll have even more vegetation on them, and they'll gradually grow as they move inland. You can see over here on the diagram that we follow kind of like a young to old analogy, running from embryo all the way to the mature stage. And as we move from the left-hand side of the diagram to the right-hand side of the diagram, you can see that they get older. The berm will turn into the embryo dune, which will turn into the fore dune, and so forth. They also have increased vegetation coverage, which helps them to trap that sediment that we talked about. And because they have more vegetation coverage, the color of the dune slightly changes. It goes from a yellow sandy to a more nutrient-rich grey, and then finally a brown soily composition. You can see from the photographs that I'm loading over here what each of these dunes look like. I'm labeling them 1 to 6, and I've also added the slack over there, which is that section between the grey dunes and the mature dunes where water is actually trapped. So in photograph number 1, you can see that berm, that upper part of the swash. You can see 2 that it's beginning to get more and more vegetation, and the vegetation gets denser and has larger varieties of plants the further inland you move.
Yeah, so there are 6 different types of dunes as you move inland, from berm, embryo, fore dunes, yellow dunes, gray dunes, and mature dunes, with increasing vegetation cover and increasing soil nutrients. Remember, we talked about soils in which darker black soils tend to have more organic matter, and as you move away from the shoreline, you have more of that organic matter in more of a brown or black color. And so dunes are definitely important structures in coastal ecosystems and coastal communities. You can see here that, and you probably know yourself, that dunes are important for storm protection. That whenever a storm comes, the amount of damage that it caused is really dependent on whether the combination of the tides, the storm surge, and the sea level make it past the protective dune height or not. With increasing heights of those waves compared to the dune height, meaning more destruction. And so as you have a storm come in, a lot of times that sand that builds up over time in the dunes gets washed towards the water, and it gets deposited further from shore. And over time, that needs to be built up. Otherwise, that dune is going to slowly erode away. So that can be either naturally over time, where wind and waves bring sand back into the dunes, or it can be done artificially with people bulldozing sand onto those dune formations. So the next different landscape that we're going to be talking about within the context of deserts are Badlands. And these are pictures from Badlands National Park. You can see me here enjoying this Badlands landscape. So Badlands are real-like topography formed in usually desert-like areas where you have weathering due to rainfall. And so the rain erodes away the rock and forms these real-like structures. We can see that these structures form a very predictable pattern. We have a mathematical model that prescribes a set amount of rainfall as well as sea level fluctuations. We can see as the model runs how these rills develop over time. And so as you apply this rainfall, you have discharge that's being diverted into these rills. And as you do, the topography gets more and more rough, and you have erosion occurring upland and deposition occurring near the shoreline. And so this rill-like structure here that develops over time is the Badlands. And so the Badlands of Badlands National Park used to be near the shoreline and formed as rainfall eroded away the rock and formed this rill structure. So next, speaking of rainfall, we're going to be talking about surface water in desert landscapes. While deserts don't have a lot of water associated with them by definition, there still is a lot of areas that still have surface water that flows or stays there for some amount of time. Maybe the most characteristic of which is oases. So oases are areas that we talked about in our groundwater lecture, where you have a supply of groundwater in a desert region, causing a permanent spring that allows for water to maintain there. So you can see this diagram here where you have a confined aquifer that flows water and is charged higher up in the mountainside, and that water, that aquifer either reaches the surface and forms an oasis, or that aquifer hits some sort of fault or fracture that allows water to move upwards more easily, and you have an oasis that forms along that fracture line. Next, we have playas. So playas are just dry lake beds. So they tend to be very expansive, very flat regions, usually with a lot of mud. You can see the mud cracking here, where it's kind of a dead end for water flow. So water in a desert region flows into a playa and then eventually gets evaporated. You can see here that they tend to be very gorgeous whenever they do get flooded. And this can happen occasionally when you have these infrequent rain events in a desert, and the water then flows into a playa and then eventually evaporates out or gets drained into the ground. When that water that flows in flows over rock that has high amounts of salt, then you can have a salt flat or a salinas formed. And this is just a playa where you have extensive amounts of salt being deposited or evaporates, as we call them in their mineral terminology. So you have these bright white colored evaporates that get deposited within the playa as the water is evaporated off. And when these salt flats are flooded, they can be extremely beautiful. The bright white salt that's underneath them makes them very reflective, and they can form these almost perfect mirrors as a result. So it's definitely a sight to see. Salt flats also importantly are a very important supply of lithium. Lithium goes into a lot of modern day batteries. Every Tesla has lithium battery. So lithium is definitely an important resource for our economy. And so a lot of times you have windblown dust as well as lithium from subterranean sources and weathered rock that tends to gather in a salt flat and is consolidated by the evaporation process. So, for example, the salt flats in Bolivia are a very good source of lithium and are actively being mined there. Additionally, because salt flats tend to be so flat and so homogeneously one color, they're very good at calibrating satellites. So we fly satellites over this region and we test both the elevation measurements from a satellite or the color measurements of a spectral satellite. And so a lot of times you'll have satellite measurements being calibrated and making sure you have enough precision based off of measuring a salt flat over and over again. Another interesting feature when you have water flowing in the desert are sailing rocks. So sailing rocks are these boulders that can be seen within a playa that show this strange erosional linear trail behind them. And the way that these form is by the playa getting rained on and filling with water and then freezing overnight. And so that ice layer develops and freezes onto the side of these rocks and provides a buoyant force as more water flows in. And as that ice that's connected to the stone, the rock lifts it up, then the wind can drag that rafted rock downwind. And you have that erosional feature that develops because of that. Another cool thing about deserts is that sometimes you have super blooms. Whenever there is a rain event, oftentimes you can have plants that have adapted to these environments and have seeds that can wait years for the next rainfall. And when it does finally rain, they tend to all bloom simultaneously. And so you can have these gigantic blooms in the desert infrequently as a result. So whenever you have a stream that's flowing through the desert, that stream is sometimes sourced from outside of that desert region. The most famous example of this, an exotic stream, is the Nile River. And so the Nile River mainly gets its water from areas as far south as Tanzania and Rwanda, and that water then flows all the way north into Egypt. And so within Egypt, not a lot of that water flowing in the river is from Egypt itself. And so this stream would be considered an exotic stream because that water is coming from a very distant location. And you can see the Nile River Delta here. Whenever that's not the case, you usually have an ephemeral or a losing stream. A losing stream is a stream in which the water table is lower than the river. And so over time, water flowing in this river will seep into the ground, and it's losing more water than it's gaining. And eventually, the whole river will dry up, and you'll have an ephemeral stream. Ephemeral meaning not long lasting, and so these streams are only flowing when you have rainwater flowing directly into them, and so they dry up from time to time. You can see here, so that this is a diagram showing an ephemeral stream where the water table at all instances is below the stream bed, and so any water that goes into the stream then flows into the ground and feeds the water table, unlike a perennial stream where the water table is above the stream bed and that groundwater is supplying more water to that stream. And so if that's not the case, you have an ephemeral stream. Whenever that stream then completely dries out, what's left behind is a wash, also known as a rojos. So a wash is just a dry riverbed in the desert, and you can see examples of some of them here. And so these tend to be sources of sediment and will occasionally flood as you have water flowing in them. These are some pictures that I took when doing field work in the Central Valley of California. We were actually doing research on washes in that region using GPS to measure the amount of water and the subsidence of the ground. And we could use those measurements to see if the farmers and the municipalities nearby were over pumping the groundwater from that region and causing more subsidence and therefore more losing streams as a result. So here's some pictures that I took during that fieldwork. Sometimes when it does rain in the desert, these washes will suddenly flood, and these can be extremely dramatic and extremely dangerous events called flash floods. And so these completely bone-dry stream beds, these washes can all of a sudden flow with torrential amounts of water. And you can see an example of that here.
This is why you don't hike when there's rainstorms.
So he's definitely right about that. So flash floods cause several deaths per year, and that's just because they can kind of happen suddenly and don't necessarily happen when it's directly raining. And it can just be where it's raining far upstream, and a lot of these streams carry a lot of mud and debris with them, and as a result can trap hikers that are flowing that are hiking in these regions. One area that also receives flash floods is Antelope Canyon. You may have seen photos of Antelope Canyon. This is me exploring it this past spring. Maybe you've seen this photo. This was a photo in Antelope Canyon that was sold for several millions of dollars, called the Ghost, with a ray of sun going through the dust in this canyon. And so this is an example of a slot canyon that experiences somewhat frequent flash flood events. And we can see a video of that here. Yeah, so it's a pretty intense amount of water, and it completely fills that canyon and erodes it away, moving all the sediment that was originally deposited there. So next, we're going to be talking about bedrock features in deserts. So when you have water flowing in a desert, especially over an area where you have exposed bedrock, then you can have erosional features that result. And so the largest of which are plateaus. So plateaus, like you can see here, are large, expansive regions of exposed bedrock, usually with a very flat top, that are higher than the desert region below them. And sometimes they're often formed when there's some amount of uplift going on. For example, you could have a normal fault that develops here or here, which causes this area to drop down and this area to relatively be higher up. And so this plateau can erode away or extend out very far into the desert. When part of that plateau is cut off from the main region and leaves kind of an island with a flat top, that area is called a mesa. So a mesa is fairly large, but is completely surrounded by low-lying desert around it. And so eventually this mesa will erode away and form a butte. So a butte, like these ones, photos that I took from Monument Valley, have eroded away until they are pretty much as tall as they are wide. And so they're eroding from the sides and eventually form these smaller towers that result. This can get to extremes in pinnacles. So these are pretty much straight vertical towers that develop as a butte erodes even further in from its sides. This is in Monument Valley, and this here is in Arches National Park. And for scale, you can see the rock climbers at the top here. So these can be very large features that are just remnants of the rock that was once completely surrounding it. Oftentimes when you have layers of rock that get eroded into in a desert landscape, you have terrain called mesa and scarp terrain. And so this forms when you have a resistant layer with a easily erodible layer below it and repeating patterns of resistant and easily eroded. And what results is that you have the resistant layer having a steep scarp face because it doesn't erode as easily, and then the more easily eroded area having a more gently sloped inclined face. And you have that pattern of this steep slope, gentle slope, steep slope, gentle slope, all the way down usually to the river that's carving out this terrain. And you can see that here, for example, in the Grand Canyon. These are pictures that I took last year when visiting the Grand Canyon, where you have these mesas here, these flat areas with the steep sides to them, with these gentle slopes that develop. And you can see that here, these scarp faces with the gentle slopes that can repeat themselves over and over again. This process can sometimes be furthered along through something called sapping. So sapping is when you have groundwater that's flowing in between layers of rock, usually directly below that more harder to erode layer, and flows in between those layers and can cause more erosion. We can see that happening here. Sometimes that mesa and scarp terrain just forms from erosion kind of providing an equal erosional force to the hillside and eroding it back. but sometimes water and sapping is an important aspect of it. For example, here we can see in this process, you have water flowing into the rock through the cracks and then hitting that bedding plane between that hard erosion and easy erosion layer and flowing outwards. And as it does, it erodes away and forms an overhang that then topples and erodes that layer back. And additionally, you can have a second process in which you have water seeping in and kind of eroding away at the entire rock surface and slowly causing it to crumble and move back that way. So that's a number of different ways that we can form mesa and scarp terrain. So next we'll talk about inselbergs and Bornhards. Bornhards are just inselbergs that are formed from granite or gneiss rock. And so inselbergs are islands or kind of rock icebergs, I guess you could say, that form in a desert. The most famous of which is in Australia. But these are bedrock formations that are remnants of rock formations that were eroded away, leaving just this sea of desert sediments around them. And you can see how they're formed here, in which you have this unit of rock that doesn't have that many fractures around it, within it, surrounded by rock with more fractures in it, and that rock around it gets eroded away, leaving just the inselberg that results. And so you can have this ridge of bedrock here that's exposed as that weathering progresses, and that bedrock will start to erode and form pediment, which is sediments formed by the erosion of bedrock. And they'll form around this area until pretty much all of this original bedrock is completely eroded away and covered in pediment, besides the individual islands or mountains that are the inselbergs that remain. The next interesting feature that can form in a desert is an alluvial fan. So this is a depositional feature that forms whenever you have a confined stream that has a relatively high slope enter a floodplain or a region with relatively low slope. And as it reaches that area of low slope, the stream loses power and it can't hold that and transport the sediment in that stream anymore, and that sediment is being deposited, and that sediment then forms an alluvial fan. So you have this stream coming in, reaching that lower slope region and depositing sediment. Eventually these deposits of sediment will pile up so much in this region that this stream will then be cut off and flow in a separate direction, and so it'll then deposit in this region, for example, and it'll do that over and over time and deposit in these different areas until it's completely spread out over this entire region. You can see examples of alluvial fans here, both from a plane view and from space, where you can see the individual old flow paths of the river that came in from the mountains and then deposited and has subsequently taken these other paths. So next we have slot canyons. So we talked about it a little bit before, but slot canyons, just like this one that I walked through. This is Labyrinth Canyon on Lake Powell, very gorgeous slot canyon. Here's an example of a slot canyon, Antelope Canyon, that's taken by a professional, so you can see just how gorgeous these canyons can be. And so slot canyons are very narrow canyons that form in bedrock, usually in desert landscapes, due to a river carving through that rock layer. So you can see here you have a river forming that has a very large erosive power, and it erodes down into the rock and incises a deep channel into the rock, forming these very steep valley walls. Usually this is brought on by some sort of process that raises that rock layer. And so rivers like to have constant slopes to distribute power more evenly. And so as you have that uplift occurring, the river will incise intensely into that rock and often form a slot canyon that results. And then the last thing that we're going to be talking about are arches. So arches are some of the most gorgeous features that can form in a desert. This is from Arches National Park. And so arches tend to form when you have water flowing over an easily eroded layer. And so you have the incision of this river into the rock, and as it incises, it also meanders, and that river likes to meander along and increase its meandering as it flows. And as it does, it can cut itself off. And when you have a very strong layer on top of a weaker layer, that river will erode into this rock layer but maintain this top layer. So it erodes and forms this archway as it cuts itself off. So you can think of this area here as the location of that Oxbow Lake, and then here where the archway forms is where that cutoff of the stream occurred, leaving just the upper layer that was on top of it. So that just about covers everything that we're going to talk about in terms of desert. So in summary, we talked about the distribution of deserts throughout the world. We talked about desertification and the positive feedback loops associated with it. We talked about ergs, regs, and hamadas. We talked about all the different types of dunes in deserts as well as in coastal environments. We talked about badlands, water features, sorry about the noise, water features in deserts, and lastly we just talked about bedrock features that form in desert regions. So thank you all for watching. I hope you enjoyed it, and I will see you guys at the next lecture. Bye.